Kia ora class. Today we're going to be talking about the chronic responses that you see in the human body as a result of exercise. What are chronic adaptations? Well, chronic adaptations are also sometimes called long-term changes, and they are the things that we see in the human body. They happen slowly and only after a period of extended training, so that is weeks of training or months of training or even years of training. Sometimes is what it takes to really see these adaptations take hold. The good thing about these adaptations though is that they stay with the body. They become a permanent part of the body unless you stop training, and we'll talk about that in a little bit. The type of changes that happen to the body are dependent on the type of training that is happening. So some of these adaptations require you to do specific things. They don't just all happen magically. You've got to do certain things in order to see these adaptations. Why do these adaptations occur? Well, when the body exercises harder than it is used to, the body's systems are stressed. We call this overload. The systems are overloaded. Overload causes the body to recover and adapt to be a little bit more efficient at what it's being pushed to do. And if you do this over a period of time, those little adaptations, those little recoveries will add up to obviously greater performance. That is, you will be faster, stronger, more flexible, or have more endurance if you push the body to do those things. If you push the body's endurance capabilities, it will slowly get better at endurance. You see here, Arnold Schwarzenegger, my boy, okay, he's done a lot of work to make his muscular system adapt. He's worked really, really hard to see a lot of adaptations in his muscular system. So, to keep adapting, we just talked about this, to keep adapting, athletes must increase the intensity of their training over time. They can't just do the same thing over and over. They need to gradually make it harder and harder on their body because their body is getting slightly better and slightly better and slightly better. You always need to be pushing it slightly harder than it's used to. So you need to train longer, you need to train harder, or train with less rest, or train more often. Those are all ways that you can increase the intensity of the training and keep the body adapting. As soon as you repeat what you've already done, as soon as you just plateau off and keep doing the same thing, you're going to stop seeing these adaptations happen. You're going to stop achieving overload. If you stop training altogether, or you start training lighter, you start doing less intense training, then your body will revert to how it was in the past. This is called the principle of reversibility. Your body reverts back or goes backwards in terms of your training and your adaptations. It goes back to what it used to look like. And we can see that here, old Arnold Schwarzenegger, not in the same shape that he was in when he was training to be Mr. Olympia, but still probably bigger and stronger than I'll ever be. So, the chronic adaptations we see depend on the type of activities that you're doing. If you train in a way that overloads your heart and your lungs, then you'll see chronic adaptations in your heart and your lungs. If you train in a way that overloads your arm muscles, just your arm muscles, then it will be your arm muscles that show those chronic adaptations, and not, say, your leg muscles, and not, say, your heart and lungs. You should train in a way that mimics the demands of the competition you're preparing for. And this is the principle of specificity. You get what you train for, basically. Now we're going to look at the three body systems that we talked about in the acute responses, but we're going to look at the chronic responses for each. So starting with the cardiovascular system, what long-term adaptations will we see in the cardiovascular system? Well, we will see that the blood gets more efficient at carrying oxygen. It can actually carry more oxygen than it used to. We also see that the heart gets larger. It gets bigger and stronger. Your resting heart rate gets lower. That is, your heart rate, your beats per minute, when you're resting, it will actually be lower with the more training you do. You'll also find that after exercise, your heart rate will return to normal quicker. So when you exercise, your heart rate will go up, but in someone who has good cardiovascular adaptations, their heart will go back to normal pretty quickly. You'll also see that your heart rate when you're exercising is lower. Okay, and we'll talk about why now. So why do these things happen? Well, when the body is stressed to provide more oxygen, it will become more efficient at getting oxygen around the body easily. And that's what a lot of those adaptations are about. They are ways that the body is adapting to make oxygen more available to the working muscles. Things like the heart size increasing means that each pump sends more blood around, it's more efficient, and it can get more blood through the veins and the arteries to the muscles where it needs to be. With a more efficient heart, it won't have to beat as often, which is why you see the changes in the heart rate both when you're exercising and when you're at rest. Your heart actually does more work per pump, so it doesn't need to beat as often as it used to. Now we're going to look at respiratory adaptations. This is adaptations in your lungs and airways. You'll see that after a period of training, respiratory adaptations might be that the lungs breathe in a greater volume of air, and thus there's more oxygen in there. And you'll also see that the lungs are able to breathe out a greater volume of air. The lungs get bigger and able to hold more air, so breathe in more oxygen and at the same time breathe out more CO2, which is the waste product. So why do these happen? Well, again, when the body is stressed to provide more oxygen to the muscles, it will become more efficient at getting oxygen into the body and around to where it needs to be more easily. Bigger lungs means more surface area for oxygen to get in and out of the blood, and more CO2 to get out of the blood and into the air for us to exhale. The bigger the lungs, the more gas exchange that can happen. The lungs also become more efficient at getting oxygen out of the air that we breathe in. So before, you may take a big lung full of air and you may get 20% of the oxygen out of it. And someone who has strong adaptations in this area, they may get 40% or 60%, for example. Lastly, we're going to look at muscular adaptations. What adaptations will we see in this system? Well, we'll often see that muscles will get larger and stronger if they are stressed and they are overloaded and they are trained. We'll see that muscles become more flexible if you train them to. You'll see that muscles get more blood vessels and can therefore receive more oxygen. And you'll see that muscles can store more energy, that is muscle glycogen, so that they can work for a slightly more longer period. Right, why do these things happen? Well, all these changes make the muscles better at what you're asking it to do. If you're asking the muscles to lift a heavy weight, they will adapt to make that easier. They will adapt to be stronger so that they can lift that weight easier. Muscles become more efficient at taking what they need from the blood and storing as much energy as possible. Again, whatever you're asking the body to do, if you're asking it to work really hard for 2 minutes and then work really hard for longer than 2 minutes and a little bit longer and a little bit longer, it's going to get more efficient at working for those periods of time. It's going to get more efficient at meeting those demands. And obviously all these things make the muscles able to work for longer and generate the biggest force possible. The last thing we're going to talk about today is the relationship between physiology, that is the body, what the body is doing, and performance. A couple of things you need to understand. Performance and physiology are intertwined. It's not one and the other. They affect each other, I guess is what I'm trying to say. Different adaptations will have different, unique effects on performance. So cardiovascular adaptations will affect your performance differently to muscular adaptations. And depending on what performance looks like, that is depending on what sort of training you do, will depend on which systems adapt and which systems don't. That is the specificity that we talked about. And you also need to understand that the intensity of the physical activity will change what responses we see and how significant they are. If you train really, really, really hard, you're going to see bigger changes quicker than someone who is sort of training casually, still overloading, still increasing the intensity, but if they do it in sort of smaller increments, then the changes will be smaller and slower as well. Hope you've enjoyed that. That's been our lesson on the chronic adaptations that we see to exercise, and specifically why those adaptations occur.